It's day 13 of 50 days of tutelage, and in our math class today, we'll be talking about simple and compound interest. By the way, these simple and compound interest, sometimes they can be interesting, and sometimes they can be uninteresting based on whatever it is you are doing. If you are saving and then your money is accruing, then it is interesting. And if you had borrowed money and the interest keep accumulating, then it is not interesting. So let's get right into it. The first one I'm going to be talking about is simple interest. And so, what exactly is the idea of interest in the first place? So, the concept of interest is that, let's say you start with a certain amount of money. So, let's call that one M. Now, without adding to this money, without you doing anything to the money, so you start with a certain amount of money, without you doing anything to this money, there's capacity of this money going up by itself, that is going up in value. Now, you're not the one doing anything, but maybe you had invested it in some uh, investment scheme, or you had put it in a bank, or you had put it in a business, any of these things. But the only thing you had to do was to put the money there, and that certain amount of money that you have put there, after a period of time, when you go back to get that money, then you get more than what you had put in inside. That's exactly where the concept of interest comes in. When a certain amount of money grows, you know how they would sarcastically say that I did not plant a money tree be at my backyard. Like, you can't, money don't grow on trees. But actually, money do grow, and that is the concept of interest. So we have the simple one and we have the compounding one. So what is the simple interest? The simple interest is simply, just as it sounds, it's just simple. What it's doing is that it's just linearly increasing the money that you have put inside. And so this simple interest, it depends on several things. Number one, the simple interest depends on the money that you have put in itself. That's the first thing. So the simple interest, oh, how much have we put it into this thing, or how much am I going to be reflecting on to yield interest? So the first thing is the money that you have put in, and this guy is called the principal amount. So it is called the principal, and it's denoted using P. Then the next thing that it is dependent on is the rate. At what rate should interest be charged? This rate is always in form of a percentage, is always in form of a percentage. So at what rate? Am I charging interest at 20% rate? Is it 1% rate? Is it 5% rate? That is the amount that it will be topping it up. But this amount that it will be topping it up, it doesn't just top it up anyhow. Maybe it top it up in the next 1 week, and then after like 3 months, it doesn't top it up again, then it waits till like 6 months again and top it up again and all of those things. So it doesn't work like that. So the way it works is that there's always a time involved. So for every of this time, there's always going to be the topping up by this rate. And so these are the three things that the simple interest depends on. That is why the expression for simple interest is given as the principal multiplied by rate multiplied by time. Please take note, this rate is always calculated as a percentage. So whatever you are given, always divide it by 100 before you use it in the expression. So simple interest is principal multiplied by rate multiplied by time. And so how do you calculate that? How do you solve problem with that? All you have to do is, if you are given, let's say you are investing a certain amount now. Let's say you are investing 5,000 USD. You are investing 5,000 USD in a certain stock. And so this 5,000 USD now, this is your principal amount. This is going to be your principal amount. Then let's say you are investing at a rate of, let's say, 5%, 5% per annum, 5% per annum, and then the time you want to collect this thing back, let's say the time you want to collect it back is after, let's say, 5 years. After 5 years, you want to collect it back after 5 years. So what happened is that at every 1 year, this is going to be adding 5% to your money. At every 1 year, it's going to be adding 5% to your money. It's going to be adding 5% to your money. And then that is what will accrue all together. So let's quickly find the simple interest, the interest on this. So the simple interest is going to be 5,000 multiplied by, so if you convert this 5% to percentage, that will be 0.05, 0.05, then multiply by 5. So the interest, so when you do all of this together, let me get my calculator. So that will be 5,000 multiplied by 0.05 multiplied by 5. And that's going to be 1,250. So it implies that after 5 years, your money would have grown from 5,000 and would have become now. So the amount you will now have now will be 5,000 plus 1,250. And so what you notice there is that this is your principal. So the amount will be the sum of the principal plus the simple interest. So the amount will be sum of the principal plus the simple interest. But here's the thing. What if you don't want to take this thing in? Let's say it is not, it is 5% per annum, and then you only want to save this money for, like, let's say 5 months. You only want to save this money for like 5 months. So the way you have to do it is that this time is measured in years, and because this time is measured in years, so you are going to have to convert some of these things. This is 5% per annum, but what you want to do is what is 5 months. So you have to be able to convert the 5 months, you have to convert it to what the year is. So 5 months, so the first thing you do is that how many months make a year? How many months make a year? So 1 year, 1 year is the same thing as 12 months. So therefore, let x year equals 5 months. Let x year, what was that? So let x year equals 5 months. So what you want to do is that you want to find the equivalent of 5 months in year. So you cross multiply here. So what you have here is what? 12x equals what? Equals 5. And that implies that x equals 5 divided by 12. So when you do 5 divided by 12, you're going to have 0.417 approximately. So that implies that 5 months is the same thing as 0.417 year. So when you want to do this calculation now, so your simple interest is going to be 5,000 multiplied by, the rate still remains the same, that's 0.05 multiplied by, so instead of just the 5 month now, so you're going to have 0.417, 0.417, and that's going to be 5,000 multiplied by 0.05 multiplied by 0.417, and that is going to be 104.25. So you add this to 5,000 to get the amount that you have now. So that is it. That is how you do it when you are not given in terms of year. So most times the interest is always given per annum. Per annum means per year. So if you don't want to reach up to a year, or let's say you are even doing, let's say 18 months, 18 months is not up to 2 years, because that's like 12 months and 12 plus 6 months. So that will be 18 months. That's 1 year and 6 months. So all you have to do is that 18 months, just do 18 divided by 12. So that's it. So now, instead of you going through this process, now this process is just for me to explain. Instead of you going through this process again, all you have to do whenever you are given in terms of months, and you're not given like as a straight year like that, so just divide the number of months by 12. So you'll be able to get the equivalent in years. That is what you will use in this formula. So you always have to use this time in terms of year, because the interest rate is going to be given per annum. The only exception is if you are given an interest rate, maybe 5% per month, 5% per day, and all of those sort of different things. So now back to this. So I've told you that the amount that you get at the end of the day, so amount is always principal plus simple interest. But you remember that the simple interest itself is given as P multiplied by R multiplied by T. So that implies that amount is P into bracket. So if you factorize P out here, so that will be 1 plus what? 1 plus RT. 1 plus RT. So, and one thing you can do here is that you can actually find the graph, because in the advanced thing, you can actually find the graph of amount versus time. Amount versus time. So this is going to be a linear graph. And the first thing you notice about this graph is that this graph is not going to be passing through the origin. This graph is not going to be passing through the origin. and it's going to go something of this nature. So this is what the graph of amount versus time is going to be for a simple interest. This place, this particular point here, where this is touching the y-axis or the vertical axis, this value is going to be your principal. And then you continue to go like that. And the slope of this will be the product of principal multiplied by the rate, principal multiplied by the rate. So this is what the graph of amount versus time is going to be for a simple interest. And that's basically what simple interest is all about. Now let's go to the other guy, compound interest. This is where the real deal lies. For compound interest, the thing about compound interest is that inside your interest, another interest dey there. That's exactly what compound is about. Because as your interest, as like your money is growing, so you put a certain amount of money, and this money had grown to become more money. Let me call it MM. So what happened is that this more money itself will now be the one to do the growing now. But you see, for simple interest, M just grows, whatever, when the time comes, it just grows to that new money. But in the case of interest, there is always a frequent change, a frequent increase. But the increase is not calculated based on your initial amount. The increase is calculated based on the amount that is there when you want to increase it. So for instance, if let's say, let me quickly show you what it is about now. So if simple interest, let's say simple interest, say if you start with 4, every single year I'm going to be adding 2. So that means that in the first year I had 2, in the second year I had 2, in the third year I had 2. So at the end of the day, this has grown into 4 plus 2 plus 2 plus 2. So 2 plus 2 is 4, 4 plus 2 is 6. This is going to be what? This is going to be 10. But in the same case, let's say it was compound interest. You started with 4. Let's say the person says they would always add uh, half of what you have there. So in this case now, you are increasing by half of what you started with. So for every time you increase by half of what you started with. So half of what you started with is 4. So plus 2 plus 2 plus 2. But in this case, the compound interest, so this is for simple interest. Simple interest. Now for compound interest now, it's saying that any money that I meet whenever I come, I'm going to be increasing it by half of that money. So the first year you met 4, so therefore you're going to add 2. You can see that they look like they are the same guy from the beginning. But on this day, after when you come the next year, what you meet is 6. So therefore, what you're going to be adding there is going to be what? Plus 3, because half of 6 is 3. Now, this day now, another, that's so first year, second year, third year. So first year you did this. Second year you say that 6 plus 3 is 9. So therefore what you're adding is what? 4.5. So you have 9 plus what? 4.5. And so that is how compound interest works. So compound interest, it deals with what it meets whenever the interest is about to accrue. It deals with what it meets whenever the interest is about to accrue. And so there's an expression for that. So we can find the amount. So after all the compounding has been done, the amount is given as the principal, then multiplied by 1 plus r over n raised to power nt. Now, what is n? N is actually the frequency of compounding. N is the frequency of compounding. I'm going to explain that to you because we actually have several different ways it does. Now, the common one is yearly. So if it is compounding yearly, n is going to be equal to 1. So that's the first one. Then we also have the one we call semi-annually. 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 In this case, n is going to be equal to 2. We also have the one we call quarterly. Quarterly, n is going to be equal to 4. We also have the one that we call monthly. So monthly, you can guess what n is going to be like that. N is going to be 12 when you're doing monthly. When you're doing weekly, n is going to be 52. When you're doing daily, n is going to be 365. Depending on if it's a leap year, it will be 366. So this is what n is, the frequency of compound. That is how many times really compound in that period of a year. So is it going to be yearly? Is it just going to compound once? Is it going to be semi-annually, that is going to compound twice a year? or is it going to compound 4 times in a year and all of those things? So this is basically what this is all about. Now, so for this compound interest, one thing we also know is that interest, for any time, interest is always going to be amount minus principal. Amount minus principal. So that implies that amount, which has been given as P1 plus R over N, then times NT minus what? P. So that implies that interest is going to be P. You can factorize P from here. So P 1 plus R over N raised to power NT minus 1. So this is the formula that you will use to calculate interest. In this case, when it is a compound interest. So this is the formula for compound interest. This right here is the formula for compound interest. But most times we don't really waste our time to do this long thing. We just calculate the amount that will be accrued after a given period, and we subtract the principal from it. So for instance, so let's use the same example earlier. So we had 5,000 USD. It was invested at a rate of 5% per annum, 5% per annum, and the time is 5 years. 5 years. So now we want to see how much would have accrued after 5 years. So the amount that would have accrued after 5 years, amount is principal 1 plus R over N raised to power NT. So what I'm going to do is that I'm going to be doing just two of these. So I'm going to be doing, let's say it is done quarterly, and let's say it is done daily. Yes, I'm going to be doing for daily as well. That's 365. So if it is done quarterly, so I'm going to have this. The principal is 5,000, and then this is going to be 1 plus the rate. I told you always divide the rate by 100, so that's 0.05 divided by n. In this case is 4 because it is done quarterly, and then n is still 4 and the time is 5 years. So I'm going to press this on my calculator. So that will be 0.05 divided by 4, then plus 1. So when you have that, you have 5,000 multiplied by 1.0125 raised to power 4 times 5 is 20. So if you raise that to the power of 20 and you multiply the result by 5,000, so you have 6,410.19 USD. So let's see how this compares to the simple interest own. So when we did for simple interest, how much did we get? We got 6,250. And here, what did we have? 6,410. You can see the difference. And in fact, the difference in them always show when you have a longer year. So imagine you have to do them for 10 years. If this was 10 years, the difference would have been so clear. In fact, I'm giving you that as an assignment, or classwork rather. Quickly do that right now. Do this for 10 years, like the same old saving. Do this for 10 years for compound interest, and do it for 10 years for simple interest, and see what the difference is going to be. When you do that, you can let me know the difference in the comments. Okay, so let's do for daily. So if it is daily now this one is going to be very, very huge. So daily, you have 5,000 multiplied by 1 plus 0.05 over, this time around now is over 365. Then this will be 365 times 5. And so that will be 5,000 multiplied by, so I'm just going to do everything here. 0.05 divided by 365 plus 1. All of these raised to the power of 365 times 5. 365 times 5. So that's 1.284. So multiplying that with 5,000, so that's 6,420.02. And that is the compound interest. So now if you now want to find the interest now, so like I said, all you have to do is that subtract this from 5,000. So the interest for this, so let's call this one I2, let's call this one I1. That will be 6,410.19 cents, 6,410 USD, 0.19. You subtract that, you subtract 5,000 from that, so that will be 1,410.19. And the interest for this one is going to be 1,420.02. That will be the interest for this one. And so that is exactly how you deal with simple interest and compound interest. So if you have any issue calculating how much you make when you are saving, maybe you are saving in a particular investment, or you are struggling with and understanding the whole thing, then this particular class is going to help you figure that out. So that's basically what it is about simple interest and compound interest. As usual, don't forget to like, subscribe to this channel, and comment as well. So thank you. I'll see you in the next one.